Imagine a time before time existed. There was no space, no light, no matter. Then, in a fraction of a second, everything changed. The universe exploded into being with a bang, an event we now call the Big Bang. It was a moment of unimaginable energy and heat. From that tiny point, the universe rapidly expanded and cooled. As it did, energy began to transform. It created the building blocks of everything we know: protons, neutrons, and electrons. The universe was like a giant soup of these particles. It was chaotic and incredibly hot. But within this chaos, the seeds of order were already being sown. Gravity, the force that pulls things together, began to play its role. The Big Bang is a mystery we're still trying to unravel, but it's the starting point of our universe's incredible story, a story that would eventually lead to us.
Gravity started to pull the universe's scattered particles together. These clumps of matter grew larger and denser over millions of years. They were like cosmic dust bunnies, gathering more and more particles. As these clumps grew, their gravity intensified, pulling even more material inward. The pressure at the center of these clumps became immense. Temperatures soared to millions of degrees. Finally, the pressure and heat became so intense that nuclear fusion ignited. Hydrogen atoms, the simplest elements, were forced together to form helium, releasing enormous amounts of energy. The first stars were born. Stars didn't form in isolation. Gravity continued to draw them together into vast swirling collections called galaxies. Our Milky Way galaxy, with its billions of stars, is just one of countless galaxies scattered throughout the universe.
Around 4.6 billion years ago, in a quiet corner of the Milky Way, our own story began. A giant cloud of gas and dust called a nebula started to collapse under its own gravity. As the nebula contracted, it began to spin faster and faster. The center of the cloud grew hotter and denser, eventually becoming a protostar, the precursor to a star. This protostar would become our sun. The remaining gas and dust in the nebula swirled around the protosun, forming a disk. Within this disk, the stage was set for the birth of our solar system and our planet Earth.
In the swirling chaos of the early solar system, dust and gas collided and stuck together. These collisions created larger and larger objects called planetesimals. Over millions of years, these planetesimals continued to grow, pulling in more and more material through gravity. Eventually, one of these planetesimals became massive enough to form the Earth. The early Earth was a hellish place. It was a molten ball of rock, bombarded by asteroids and comets. The heat from these impacts, combined with the decay of radioactive elements within Earth's core, kept the planet in a molten state.
Section 5. Lunar Lullaby, the Moon's dramatic entrance. Around this time, a cataclysmic event occurred that would shape Earth's future. A Mars-sized object, which scientists call Theia, slammed into the young Earth. The impact was colossal. It blasted molten rock and debris into space, forming a ring around the Earth. The debris in this ring eventually coalesced under its own gravity, forming our Moon. The Moon's gravitational pull had a profound impact on Earth. It stabilized Earth's rotation, creating a more stable climate. The Moon also created tides, which played a role in the development of life.
Section 6. Oceans abound. A water world emerges. As Earth slowly cooled, its surface began to solidify, forming the first crust. Volcanoes erupted, releasing gases from the planet's interior. These gases formed the early atmosphere, although it was very different from the atmosphere we breathe today. Water vapor released from volcanoes and delivered by comets began to accumulate in the atmosphere. As Earth continued to cool, this water vapor condensed and fell as rain, filling the first oceans. These early oceans were likely acidic and hot, but they set the stage for the emergence of life.
Section 7. Life finds a foothold. The exact details of how life arose from the primordial soup remain a mystery. But somewhere in those early oceans, something extraordinary happened. Simple organic molecules, the building blocks of life, began to assemble. Perhaps these molecules formed in volcanic vents, where heat and chemicals provided the necessary energy. Or maybe they arrived on Earth from space, carried on meteorites. Over millions of years, these molecules became more complex. They formed chains, creating the precursors to DNA and RNA, the molecules that carry genetic information. Eventually, these molecules were enclosed within membranes, forming the first cells.
Section 8, Oxygen Explosion, a turning point. The first life forms were simple, single-celled organisms. They thrived in the oxygen-poor environment of the early Earth, but around 3.5 billion years ago, a new type of life emerged, cyanobacteria. Cyanobacteria developed the ability to perform photosynthesis. They use sunlight, water, and carbon dioxide to create energy, releasing oxygen as a byproduct. This oxygen release, known as the Great Oxidation Event, had a profound impact on Earth's atmosphere. Over millions of years, oxygen levels in the atmosphere rose dramatically. This paved the way for the evolution of more complex life forms that could use oxygen for respiration.
Section 9. The Cambrian Explosion. Life gets complex. Around 540 million years ago, after billions of years of slow evolution, life on Earth exploded in diversity. This period, known as the Cambrian Explosion, saw the rapid appearance of most major animal groups. Creatures with hard shells, exoskeletons, and complex body plans evolved. The oceans teemed with trilobites, jellyfish, worms, and early fish. Life had finally gained a foothold on land, with the first plants and fungi colonizing the continents. The Cambrian explosion was a pivotal moment in Earth's history. It marked the beginning of the diversification of life that would eventually lead to all the plants and animals we see today, including ourselves.
Section 10, a planet in motion, continents on the move. While life flourished and diversified, Earth's continents were also on the move. The Earth's outer layer, the lithosphere, is broken into several tectonic plates that float on the semi-fluid mantle beneath. These plates are in constant motion, colliding, separating, and sliding past each other. These movements, known as plate tectonics, have shaped Earth's surface for billions of years, creating mountains, valleys, and ocean basins. Over millions of years, the continents have come together to form supercontinents, only to break apart again. These cycles of continental drift have had a major impact on the evolution and distribution of life.
Section 11. The Age of Giants Dinosaurs Rule the Earth. Around 250 million years ago, a new group of animals began to dominate the planet dinosaurs. These reptiles, ranging in size from tiny feathered creatures to colossal long-necked giants, ruled the Earth for over 180 million years. During the Mesozoic era, often called the Age of Dinosaurs, Earth was a warm and humid world. Lush forests covered much of the land, providing habitat for a wide array of dinosaurs, including herbivores like Triceratops and carnivores like Tyrannosaurus rex. Dinosaurs weren't the only creatures that thrived during this time. Pterosaurs, flying reptiles, soared through the skies. Ichthyosaurs and plesiosaurs, marine reptiles, patrolled the seas.
Section 12. Farewell to the dinosaurs. Hello, mammals. Around 66 million years ago, a cataclysmic event brought the reign of the dinosaurs to an abrupt end. A massive asteroid, about 6 miles wide, slammed into Earth near the Yucatan Peninsula in what is now Mexico. The impact triggered widespread wildfires, tsunamis, and earthquakes. It released vast amounts of dust and debris into the atmosphere, blocking out the sun and causing a global cooling effect. The dinosaurs, along with many other plant and animal species, couldn't survive the environmental devastation. In the aftermath of the asteroid impact, a new group of animals emerged, mammals. Mammals had existed alongside the dinosaurs, but they were mostly small, nocturnal creatures. With the dinosaurs gone, mammals were able to diversify and evolve, filling the ecological niches left vacant.
Section 13, Humanity's Dawn. A new chapter begins. The extinction of the dinosaurs paved the way for the rise of mammals and eventually the evolution of our own species, Homo sapiens. About 6 million years ago, our lineage split from that of our closest living relatives, chimpanzees. Our ancestors began to walk upright, freeing their hands to use tools. Their brains grew larger, allowing for more complex thought and communication.
Over millions of years, our ancestors migrated out of Africa, spreading across the globe. They developed language, art, and culture, leaving behind evidence of their presence in the form of cave paintings, tools, and fossils. Today, humans are the dominant species on Earth. We have developed complex societies, technologies, and cultures. But our activities are also having a profound impact on the planet, from climate change to habitat loss.
As we look back on the epic journey of Earth, from the Big Bang to the present day, we are reminded of the interconnectedness of all things. We are part of this planet's story, and it is our responsibility to ensure that the story continues for generations to come.